So I'm Scott Chamberlain. This is my Twitter up there if you want to talk with me. I work with our OpenSci, a nonprofit organization. Most of our funding comes from the Helmsley Charitable Trust. So I wanted to acknowledge them. If you want an OpenSci sticker, come talk to me and I'll give you a sticker. And I'd like to meet you. So I'm going to talk about mostly three packages and touch on a few other packages. So the packages are Cruel, C-R-U-L, Webmocker, and VCR. So the reason for these packages, the reason I've made them with others is because our OpenSci has a lot of packages that do HTTP requests. And if you're not sure what that is, if you just go into a browser and open a tab and type in a URL, and execute it, that's going to make an HTTP request, or possibly many. So you're doing that all the time, right, in your browser. And we do this in R as well to retrieve remote resources, or maybe it's even on your own machine if it's some locally running database. So the first package I'm going to talk about is Cruel. It's a new-ish. It's not really new. It's been on CRAN for 3 years. But it's relative to HTTR. It's pretty new. And you can find it on GitHub at ropensci/CRUL. Some of the main features are it has asynchronous requests building on Jeroen Ooms' curl package, which he's implemented sort of async stuff, and Cruel just sort of builds a little bit of more friendly interface on top of that. And I'll talk a little bit about that more. It has pagination helper, so you can, if you've ever done pagination by yourself in R, it can be pretty painful. And so the pagination class is trying to help you do that automatically. It supports mocking and caching, which we'll talk about more, writing to disk and streaming requests, request and response hooks. And the major feature it does not have is OAuth, and I don't really need it, so I haven't built it in, but HTTR has it, so you can go use that. So there's lots of example usage of CRUL, Cruel. On CRAN, these are the reverse imports and suggests. I'll admit that these are mostly my packages, but there's lots of real-world usage, so nonetheless, it's there. And so a quick demo is that the main class or object you would probably use is the HTTP client, and this is a little bit different from typical R base R usage. So this is leveraging the R6 package, and to create a new object, you would call $new on that and pass in the base URL. And then with that object con, you can add any number of, you can add a path, you can add query parameters, you can, depending on the HTTP verb, you can add body, JSON object or list or whatever. And this returns an R6 object, and this is just a pretty print return here with the base URL request headers, response headers. And on this object, you can get the results from the request, from the executed from the request and the response. You can parse the response with coding that you wish. You can do a raise for status, which is the same as stop for status in HTTR. So it's a little bit different. Instead of whereas in HTTR, you're passing things into functions, you're creating an object here and calling methods and stuff on those objects. So just an example of asynchronous requests. There's two different interfaces. One is called async with a capital A, and this treats all requests the same. So if you pass in any number of URLs, and it will treat them all the same. You can call the get verb on each one of them. And then you can, parse the results from all those. And a different interface on the bottom there is async varied, where you can use this class HTTP request to create custom requests for every different request, and then you pass those into async varied, and it will handle those each of those independently. This pagination helper I mentioned. So again, we would use HTTP client to create a connection object, and then pass that to this class paginator, and we'd specify, hey, we wanted the limit parameter and the offset parameter are rows and offset. And you might be familiar with those two parameters from if you used Solar database. And then you say, I want to have a limit of 50, which means you want to have a max of 50 results, and you want to have chunks of 10, so limit chunk of 10. And then it'll handle the pagination internally for you, or at least try to. You never know. I mean, servers do all kinds of weird things, so at least we'll try to do that. Put the caveat on the bottom there that there's other ways that pagination works. If you're familiar with HTTP requests, it could be done through link headers and cursors. Cursors are usually returned in, can be given in query parameters, but anyway, that'll be to come. So we also request, just like HTTR has request and response hooks. So this is no different from that. With a request hook, you run something before the request occurs. With a response hook, it's after the request is done. So in a quick example here, we just use cat to say, hey, we're requesting a certain URL at a certain time. And then the response, sort of response callback, we're saying, what was the status code? And we cat those to the screen, and we do the request, and we get those things back. And this is stupid. You wouldn't really, there's no purpose to this, but you can imagine using these for actually more useful things. And so what I'm going to talk about for the rest of the time is mocking and caching, which is a little bit more interesting with Webmocker and VCR. Both of these are forked from another language, so they're copied more or less from Ruby, from the Ruby gems Webmock and VCR. And so I think the benefit of doing this is that we can take advantage of the years and years of developer time that's gone into making these tools. They're both meant to be, Webmocker and VCR are both meant to be general purpose, so they work with curl and HTTR, and they don't quite work with curl. And I've been talking to Jeroen about this. It may be possible someday. But you know, and if any other future HTTP packages come out, it'll in theory work with those as well. And so just to reiterate this point, I think it's really interesting to sort of keep an eye out for what's going on in other languages. I oftentimes will peruse PyPy and Ruby gems and NPM and see what people are doing over there. If I'm having a problem, it might have already been solved, and you can just sort of port that code over essentially and adopt that into R. So first, Webmocker. Webmocker is for mocking HTTP requests, and it arose because I needed to make VCR, and I'll tell you, we'll get to that later. So you can find this on GitHub at r/psi webmocker/webmocker. So what does it do? So you set what you want to match against, what HTTP request you want to match against. And if it matches, you can set what to return. So like some sort of response body or status code or whatever. And then you make a HTTP request. And if the HTTP request matches what the expectation you set, then it'll give what you set to return. And if it doesn't match, it returns an error. So the idea here is that you're not allowing real HTTP requests. You're only allowing HTTP requests that match certain patterns. So it probably requires a little more explanation. So Webmocker hooks into curl or HTTR, and it hijacks the normal request. And actually, it works through HTTR using those request response hooks. And then, so we construct a response that matches the real response, sort of, whatever the response looks like, we match that, but we just create that inside of Webmocker. And then if you say, and then we just put in the response whatever you said to respond with. And then VCR builds on top of Webmocker, which I'll get into more. So this is a quick example of Webmocker usage. If you load curl and load Webmocker, the main function you want to go with is stub request, and you can say, I want to match against get requests. And so in that first parameter position, you could put post or put or delete or whatever. And then the second position is I want to match against a certain URL pattern. And you can do URL verbatim, like match exactly, or you can do a URI regex, where you can actually match against any sort of regex pattern that you want. And then the with, wi_th, it's kind of silly, but with is already a parameter or already a function in base R, so we couldn't use that. And then so we want to match against get requests, a certain URL pattern with a query parameter of hello equals world, And then we run a return status 418, and we do that request, and we actually get that, as you can see below, with the status 418. And here's just to mention that the same thing will work for HTTR, but in this case, we didn't set a stub first, and so we got an error. And it says, hey, you can stub this request with this function call. There's two examples of Webmocker usage in the wild that you can find at these URLs, where these are both in their test suites, where they're sort of setting some stubs and what to return in the request. They're not actually making real requests. So you can also set expectations to fail, so you can set expectations to timeout. So you want a stub request with a certain verb in a URL, and you want it to time out, and when that pattern matches a request that's made, it times out. Or you can set a certain exception using the faux pas package there on the sort of third line down in the bottom code block, set whatever sort of HTTP error type you want. So moving on to VCR. VCR is for recording and replaying HTTP requests and responses. And this was the first thing to come along that I felt like we needed in R, was a way to cache requests and response from real requests, mostly in test suites and packages. So this was probably the hardest software project I've worked on. This comes from the Ruby gem VCR, which is at this VCR/VCR on GitHub, and I ported that into our OpenSci. And so the first problem I came upon was I just didn't even understand how it worked at all. It was really frustrating. It took me a couple years to sort of come back to it occasionally to try and figure it out. And so I thought VCR was listening for requests sort of on ports, on wherever. I was like, I just don't understand how it works. And finally I realized it definitely doesn't. It sort of modifies whatever HTTP. In Ruby land, there's probably 10 different HTTP packages. And so with all these different packages, it hooks into these packages and just matches the request, just like we talked about in Webmocker. And then, so that's why I had to make Webmocker first. And then I was able to come back to VCR. So what VCR does is you make HTTP requests in a test suite or outside of a test suite as usual, and you're not making the real requests, and so you're testing your actual package, not necessarily the remote service. And so oftentimes in a test suite, you're essentially testing the remote service in addition to your package, which is you may or may not want to do, right? It depends on your use case. And so the Ruby, one of the problems I came upon was like I know Ruby fairly well, but I don't know it great. And so like just looking at these two lines, this is the R function on the bottom is something I converted from the Ruby. And so each of these lines is returning a Boolean with the pipe. So we were sort of combining. So are any of these true? It just returns them a Boolean from this function. And so in Ruby, you can do like a bang bang, which means something, but does that mean the same thing in R? So they're sort of exploring all these different things. And in Ruby, like a question mark at the end of a function is valid syntax, which I think is really expressive and nice, but we can't do that in R. So just a lot of these types of things. And there's no monkey patching in R. So in Ruby, you can do this. It's totally valid. It may not be smart, but you can do it. But in R, we can use assign and namespace, but I was told in no uncertain terms that CRAN wouldn't allow it. So we had to sort of to work around that. So basically, when we cache responses and requests from your HTTP requests, we put them in basically just files, but we call them cassettes because it's VCR. So you could probably get the connection. And here's a request. We get the request attributes and the response attributes in this basically YAML file. And this is a brief example where we load VCR, we load curl, and then we create a connection object into CLI, and then we use a function called useCassette. And then we can make HTTP request, and in that first time you run useCassette with an HTTP request, it makes one of those cassettes that we just saw. And then in that second block, to do the request again, it just uses the HTTP request and response from that YAML file. So the second time, it doesn't do a real request. And we can tell in the bottom block that they're the similar identical responses. And so it speeds up your tests. This is just an example with and without running it. You can tell 141 seconds to 35 seconds. We got a number of things in the works, JSON cassettes. Hopefully we get to test that reporter to help you with what's going on with your cassettes in response to VCR. Dates are always a problem. Data security, we have some going on, but there's always more to do. And the big thing is to learn more is this HTTP testing book at this link. And that's it.
Thank you very much. Now we have time for questions. So just, okay.
What do you recommend authentication-wise? Because often you need to do some OAuth or whatever during the process. What's within your pseudo, within your experience that you recommend to do that?
Sorry, I didn't quite understand. There's doors closing and
if you are in need of authentication, like OAuth or something like that, is there anything in your ecosystem that you recommend, or in your out of your experience?
So I mentioned privacy. In Webmocker, there's no real reason because nothing's getting written to disk that could accidentally go on the web. But with VCR, we just sort of copied what Ruby did, and you can basically essentially in your configuration set up regex patterns to say if I find GitHub API key string, replace that actual sys.setEnd call with some foobar. And so in the actual, but it'll actually use your credentials to make the real request, but then in the cassette, that YAML file, it'll just have that placement holder. So you remove all that secure stuff.